We're going to start 4.6 in Algebra 2 Honors, solving logarithmic and exponential equations. The assignment's going to be 4.6, 1 to 45 odds. And to do these, I really don't have any new instructions. You know how to solve equations, order of operations. But you do need, again, to know your properties. Log of A times B is log A plus log B. Log of A over B equals log of A, the log of the top, minus log of B, the bottom. And log of A to the B power equals B times log A. Those are your properties of logs. But what do logs actually mean? Well, log base A of x equals y if and only if a to the y equals x. In other words, if I have something like this, log base A of x equals y, I forget which math teacher started doing this as a fish hook. A raised to the y equals x. So that's how we're getting this. Anyway, we're going to use all of this knowledge to do some examples and then get into the assignment. You want to write everything with the same bases or the same exponents. 4 is a power of 2. It is 2 squared. A power to a power, you multiply your exponents. 1/2 is also a power of 2. It's 2 to the negative 1. Power to a power, you'd multiply your exponents. Negative 1 times x is negative x. Negative 1 times negative 3 is positive 3. The expressions are equal. The bases are equal. Therefore, the exponents must be equal. So you would say 2x equals negative x plus 3. Add the x over. Divide by 3, and you'd have your value for x. Now, we're going to try other ones. We really should check them, but that one I noticed if you plug it in, it does work. Okay, example 2. You really need to pay attention to this and listen. Is the variable that I'm trying to solve for in the exponent? The answer is yes. So if you have if you're trying to solve for a variable that's in the exponent, you're going to have to consider logging both sides. I use natural log because it's convenient and it's probably the most useful one. There's a property that allows me to pull the exponent out front, right? That's one of those 3 properties. So that gives me x times the natural log of 4 equals the natural log of 11. The opposite of multiplying by natural log of 4 would be to divide by natural log of 4. So I'm going to do what I do to one side, I have to do to both sides of the equation. So you get natural log of 11 divided by the natural log of 4. Let me make up another example for this. 2 to the let me get here. 2 raised to the 3x equals 12. 2 to the 3x equals 12. Notice I left a space. I want to get that variable out of the exponent, so I might have to log both sides. That would allow me to pull the exponent out front. 3x times ln of 2 is equal to ln of 12. Opposite of multiplying by ln of 2 would be to divide by ln of 2. So you get 3x equals, let me rewrite this a little neater, 3x equals ln of 12 divided by ln of 2. And then to get rid of the 3, you would just multiply by 1/3. So you would have 1/3 times this. That's just another example. Okay, here's one. I notice that they're both log base 5. They're both log base 5. They're equal. Does that mean that these arguments have to be equal? That's the only thing that's different. So 4x minus 7 has to equal x plus 5. What was that? 4x minus 7 has to equal x plus 5. Subtract x and add 7. I subtracted x to make 3x. I added 7, and that gave me 12. Divide by 3, and that tells me my answer is x equals 4. Now, if you put 4 in, what do you get? What's 4 times 4? 16. What's 16 minus 7? 9. Is that the same thing you'd get if you put a 4 in here? Would it be log base 5 of 9? So you know it does work. So hopefully you'll just look at this and see that everything's the same except the arguments. And because they're equal, they have to be equal. If you would like to see the proper mathematical way, here it is. We got 4, right, when we did it the other way. So you would do it using inverse functions. To get rid of log base 5, you would raise 5 to that power. You would do it to both sides. Log base 5 and 5 to the power eliminate each other, leaving me just this. Again, add 7, subtract x, divide by 3, you still get an answer of 4. But hopefully you could just look and see that the arguments have to be equal. Over here, can we do it as a fishhook? 4 to what power? 4 to the 3 equals what? 5x minus 1. 4 to the third, 4 times 4 is 16, times 4 again is 64. Add 1 makes 65. The opposite of multiplying by 5 would be to divide by 5. And I believe, is that a 13? Equaling x. 50 and 15 is 65, yep. Now you can plug it in and check, and I always recommend you do plug it in because you cannot take logs of zeros or negatives. So if you plug it in and you get a log of 0 or negative, you're not allowed to use that answer. Okay, after that we have this. I like this question because you have to know your properties. You have log base, when it's added, it becomes multiplication. 2x times x minus 5. Now, if there's no base, it's assumed to be a base 10, right? It's common logarithm. So we're going to do the fishhook. 10 to the 2, 10 raised to the 2 equals your argument. So what do I get if I distribute 2x squared minus 10x? If I subtract the 100, I make it equal 0. The only way to solve a quadratic is to make it equal 0. So, can I factor a 2 out? That would leave me with x squared minus 5x minus 50. How does that factor? X minus 10 and x plus 5. That multiplies to negative 50 and adds to negative 5. So my answers are x equals 10 or x equals negative 5. The only answer I can use is 10. Because if I put a negative 5 into here, does that give me the log of a negative? And you cannot use the log of a negative, so that one doesn't work. The only one that'll work is x equals 10. Okay, enough of the examples. Let's get into the assignment. We're doing 1 to 45 odds. So I have 5 to the x equals 8. To get rid of the exponent, I need to log both sides. That allows me to pull the exponent out front. X times natural log of 5 equals natural log of 8. And the opposite of multiplying by natural log of 5 is to divide by natural log of 5. So I'll do that to both sides, and I get my answer to be natural log of 8 divided by natural log of 5. Let me just verify the instructions do not want decimals, because I know that would be 1 point something. Yeah, this is section 4.6. I'm sorry I called it 4.5. Technically, this is 4.6, and it does help if I read the instructions. It does not say to solve it, which I did. That's fine for the solution. It wants to know what type of equation this is. Is it a variable to a constant, which would be called a polynomial, or is it a constant to a variable, which is called an exponential? This is a constant to a variable. So this is called an exponential equation. That's all they wanted you to do, was to fill in the type of equation it was. Now when you get to 3, they do want us to solve. But luckily they're both base 5s. 25 could be called 5 to the second. And when you have a power raised to a power, like I do over here, you multiply your exponents. 2x minus 12. The expressions are equal, the bases are equal. That means the exponents have to be equal. So x minus 4 equals 2x minus 12. Subtract x, add 12, and I think you get 8. Again, I subtracted x, making a 1x. I added 12, which does give me 8. How about number 5? 8 and 32 can both be written as powers of 2. 8 is 2 to the third. And power to a power, you multiply your exponents. So I think that would make it 3x minus 3. 32 could be called 2 to the fifth. Again, if you have a power to a power, you multiply exponents. 15x minus 10. Now both bases are 2, means the exponents have to be equal. 3x minus 3 equals 15x minus 10. If I subtract 3x, add 10, I think makes this a 7, right? I subtract 3x, makes 12x. I added 10. And if I add 10, I get a 7. Then I just divide by 12 to get my x. So the answer should be 7/12. Okay, I have 4 to the 2x minus 5. I could turn 4 into 2 to the second, and I could turn 64 into 2 to the sixth. However, 64 is also 4 to the third. So if I use 4 as my base, I can also make them equal to each other. Power to a power, you multiply. I think that would make 9x. Now your exponents have to be equal. If I subtract 2x and then I divide by 7, should give me this result. Okay, let's look at one like 13. I'm going to jump around a little bit because I'm trying to hit all the topics on this recording. I'm rewriting this. You have to understand inverse functions. E to the x inverse function is natural log of x. All inverse functions graphs are symmetric about the line y equals x. So what I'm saying is the inverse of e-ing is natural logging. So to get rid of the e, I natural log. The natural log and the e eliminate each other, and that gives me this. Multiplied by -1, and you would have your answer. I kind of prefer the exact answer that I have boxed in, but I'm noticing in the textbook they do an approximation for number 13 of -1.609. So they have this bottom approximate answer. I have the exact answer on top. I would like you to be able to do both, actually. How about 15? Is the exponent that you're trying, is the variable that you're trying to solve for in the exponent? Yes. So to deal with it, you log both sides. That allows you to take this exponent and pull it out front. 5x ln 11. That equals ln of 33. The opposite of multiplying by ln 11 is to divide by ln 11. If you want x by itself, maybe you're good where you can do it all at once. 5 ln 11. Would they both cancel? So I think I might divide by 5 ln 11. So my answer would be x equals ln of 33 divided by 5 ln 11, which when you punch into your calculator, hopefully we would get about 0.292. 0.292. Let me verify with my calculator. Yes, it comes out to about 0.2916, rounded to 3 decimal places, gives me this. I would probably, I like the exact answer up top, but if you want to divide and actually punch it in your calculator to get the decimal, that's also a good skill. How about here? Are they both natural logs? I'd like to teach you the proper way. To get rid of the e, what did I do? I natural log them. To get rid of a natural log, you e them. And when I say e them, it's e to that power. E and natural log eliminate each other. E and natural log eliminate each other. Subtract x makes 3x. Add 7 makes 18. Divide by 3, and you'll get your result. Put a 6 in, that gives you a 17. What's 24 minus 7? Also 17, so I know that it works. Now on number 31 here, they are both log base 8. Does that simply mean that the arguments have to be equal? 5 minus 12x would have to equal 6x minus 1. If I add 12x, I think that gives me 18x. And if I add 1, I think that gives me 6. Divide by 18, 6 goes into 18 3 times, and you'll get your answer to be x equals 1/3. Again, I'm trying to hit at least one in each section so you have a good overview of this section. 33, 35, we'll do a few of them here. What's the opposite of multiplying by 5? Divide by 5. That makes ln of x equals 7. To get rid of the ln, you e it. You have to e it, which means raise e to that power. E and natural log eliminate each other, and your answer is going to be e to the 7th. On 35, I think I would divide by 5.2. That would get the log all by itself. Again, I'm trying to get this all for the variable, so I need to kind of get it by itself. This one you divide is 3.0769. Now I'm going to do what they call the fish hook, which is 4 raised to this power. 4 raised to the 3.0769 is going to equal 2x. So I have 4 raised to that power. That gives me 71.202. And that's not x, that's 2x. So to get x, you're going to have to divide that by 2. 35.601, 35.601. Again, in AP Calculus, we have to round things to 3 decimal points, so I'm trying to get you used to that. If you want e to the 7th as a decimal, you could do e raised to the 7th, and this is approximately 1096.633, but that's an approximation at that point. Okay, after 35, I did 37. Does anybody know the addition means multiplication? So it's log base 2 of this equals 3. What property did I use? Log of a times b equal log a plus log b. I just took this and went the other way to that answer. Now we're going to do the fishhook thing, which is 2 raised to the 3 equals this. So it's 2 raised to the 3 equals x times x minus 2, x minus 2. When you distribute, that's x squared minus 2x. 2 to the third is 8. If I subtract the 8 over, it would make minus 8. How would this factor? Factors of negative 8 that add to negative 2. Negative 4 and positive 2, I think. What makes these 0 is x equals 4 and x equals negative 2. I can only use 4 because if I put a negative 2 in, that gives me the log of a negative. And that's not allowed. You're not allowed to take logs of zeros or negatives. Always check the answer on these. Okay, let's do another one, 43. Again, the addition means that you're going to multiply. So you have x minus 9 times x minus 3. Now, if you wish to multiply that out, what is x squared, or x minus 9 times x minus 3? X squared, what do you get if you add negative 9 and negative 3? Is that negative 12? And when you multiply them, I think that's a positive 27. Let me just verify, positive 27 and negative 12. Okay, now we're going to do the fishhook. 3 raised to the 2 equals this argument. So 3 raised to the 2 equals x squared minus 12x plus 27. What is 3 to the 2? 9. How do I make this equal 0? Because that's the only way I can solve it. Subtract 9. So what is 27 and take away 9 would be what, 18? So I want to see if this factors. Are there factors of 18 that add to negative 12? 9 and 2, 6 and 3. I don't think there are any, so I may have to use the quadratic formula because this doesn't work. It does not factor. So I might have to do the quadratic formula, which is x equals negative b plus or minus square root b squared minus 4ac. The whole thing divided by 2a. Now you should have that from Algebra 1. So what's negative b? Well, that would be a 12. Plus or minus that squared is 144. 4 times a, which is 1, but c is 18. All divided by 2a, 2 times 1. So 12 plus or minus square root all over 2. What is 4 times 18? 4 times 18 is 72. So you have 144 minus 72, which leaves you with 72. 72 could be 36 times 2. Square root of 72 could be called 6 radical 2 if you liked. And they're both divided by 2. So that's 6 plus or minus 3 radical 2, right? Except you only want the positive because you can't take logs of the negative. So 6 plus 3 radical 2 is going to be your x value. And what is 6 plus 3 radical 2? It's about 10.2426, 2426. So when I look in the textbook's answer says 10.243. Now, why didn't we use the minus? 6 minus 3 radical 2 is a 1.757. But when you plug that in, what's 1.57 minus 9? It's a negative, and you can't take the log of the negative. So the only answer is the 10.2. Good luck with these.